3U, Day 6, we're going to be talking about reflections in the X and Y axis for functions. I really believe that investigation is the best way to learn and remember things. It's just a little bit tricky with a flipped class. So I'm going to ask you on your honor to try Course Notes 26 for a few minutes. Take a few minutes to do this. There are a couple of questions, 5 and 10 specifically, that ask you to use a graphing calculator, and you can't at home. But if you could work through some of it, it will make the most sense to you. And one of the words that came up last year was that, what is a conjecture? Conjecture is an educated guess. So I want you to try a couple, have a look, make some good guesses, and then return to the lesson. For the function f at x equals the square root of, there, that square root sign should cover the entire x minus 2, but I did put it in brackets. So we are subtracting 2 inside the function. We have a horizontal change, which is always backwards to what you would think. So my thought process is my parent function is the square root of x. I know how to draw that. My horizontal translation would be 2 to the right. So this would be this function right here. So that is my f at x function. I am throwing some negative signs in, which we have seen in our investigation are reflections. So the equation for y equals negative f at x is y equals negative whatever the function was, negative square root of x minus 2. Since that negative sign is not inside the function, it's outside of the function, that is a vertical change. That means that shift or that change is an up and down change. That means it's a reflection because it's a negative sign. It's vertical. That means whatever is up is now down. Whatever is down is now up. So my negative f at x function is downwards. For the second one, if I have replaced my x with a negative x, that means I am putting my function, or my negative, within the function. So I have the square root of, I replace x with negative x. That means I have put something inside of the function. I have a horizontal change. Horizontal reflection is a reflection from left to right. So anything that was going right now goes left. Anything that goes left goes right. And it's a reflection across the y-axis. So I used to start 2 to the right. I now start 2 to the left. That is my function f at minus x. A horizontal reflection, you notice from your experimentation, is a reflection across y-axis. If that helps you. It helps me to remember that it is a horizontal change because it's inside the function. If you have a vertical change or a change that's outside of the function, it is going to be an up-down change. It is a reflection across the x-axis. The next question is very similar. We have f at x equals x plus 3 squared, subtract 2. And we're going to look at minus f at x and f at minus x. My parent function what is my parent function? It is a parabola. I have drawn the parabola that has been moved horizontally, left 3, and has a vertical translation down 2. And I have drawn it on the graph, more or less. So this should have a vertex of left 3, down 2, f at x. If I want to draw y equals negative f at x, I am going to have the function negative whatever f at x is. So I'm going to use great big brackets. X plus 3 squared negative 2 big bracket equals negative x plus 3 squared plus 2. But I know more easily that when I have a negative sign out the front of a function, I have a vertical reflection. My ups are downs and my downs are ups. I am across the x-axis. So I am going to pin these, we call them invariant points. That means no different. So these 2 points on the x-axis are glued. And the ups are downs and the downs are up. So if I used to be minus 3, minus 2, I'm now minus 3, positive 2. And I slope downwards. Does that make sense for what we know about parabolas? Yes. This told me in grade 10 that I had an upside down parabola. This told me that the vertex was minus 3, positive 2, which is exactly what we're looking at. For the second one, you know what we're going to see, but let's walk through it anyways. If y equals f at minus x, I am going to draw the function where I have replaced any x with negative x. So, negative x plus 3 squared, take away 2. Okay. We do know when you have replaced negative x inside the function or within the brackets, we have a horizontal change. Since my horizontal change is a negative sign, it's a reflection. And a horizontal change means that things that were left are now right and right are now left. That means it is across the y-axis. So I have an invariant point. That means a point that doesn't change on the y-axis. It's a little hard to see on this one. It's about right there. And everything that was to the left now comes to the right, and so on. So I have x-intercepts about there, and about there. My vertex is the easiest one. It used to be 3 to the left and down 2. It's 3 to the right and down 2. And I know those points have all been reflected across the y-axis. I can draw my parabola. Crooked though it may be, that is f at minus x, a reflection across the y-axis. A reflection in the x-axis is when the up goes down and the down goes up. That is a vertical change. That is when we are graphing the negative of the original function. A reflection in the y-axis is a horizontal reflection. Horizontal means you always change things inside the function, and they're always backwards to what you might think intuitively. And that is our horizontal reflection across the y-axis. Invariant points came up today. Points that don't change or are glued. when you're reflecting across the x-axis, the x-intercepts will be invariant. They're the places that are glued and it's reflected around them. For the reflection in the y-axis, y-intercepts are invariant. Please try course notes 27, 2 to 5, and 8, and on course notes 28, number 10, and I believe the solutions are